Part 3, the laws. So we'll start with Lenz law. But first, let us now talk why do we need this law. So نحن قلنا in the previous part إنه using the variation due to a variation of B or S or theta means due to a variation of the magnetic flux, we'll have a creation of electromagnetic induction phenomenon. This means we'll have creation of electromotive force induced voltage. So it's induced electromotive force, induced E. And if the circuit is closed, so we'll have I induced, current induced. This is what we took. But now the question is that how to find the value of this electromotive force, how to find the value of I induced, and how to find the direction. So we have 3 questions. First question is how to find the value of E. Second question is how to find the value of I induced if it exists, if the circuit is closed. And the third question is how to find the direction of I in the circuit, I induced. Now, using the laws, Faraday law, we'll talk about Faraday law and Lenz law. These laws will answer these questions. About Faraday laws, Faraday law will answer the 3 questions, but when I talk about Lenz law, then it will answer the question which correspond to the direction of I induced. So how can I find the direction of I induced using Lenz law? According to Lenz law, the direction of the current, of the induced current, is in such a way that its electromagnetic effects oppose the cause that has established this current. So the aim is to determine the direction of I induced. Let's take an example. So here, for example, I have a magnet that's moving toward the coil. The question is determine the direction of I induced using the Lenz law. So here, so first we have the electromagnetic induction phenomenon. Since when I'm moving towards, this means the magnetic field is increasing. So first let us trace the magnetic field. This is the magnet. So we know that the magnetic field is directed from north to south. So if I want to represent it here, then this will be B. Now, how to represent I induced? So first of all, I look at the variable. Who's the variable? It's B. So I say B is increasing. So ما بكفي أقول إنه it's variable here. I should know if it's increasing or decreasing. So B is increasing. This means what? This means I will have a creation of B induced, which will try to what? To oppose. This means oppose the variation. This means creation of B induced, which will try to decrease B. Now, in order to decrease, this means what? حتى أنا أقدر أصغر الفاليو. هيدا بيعني إنه B induced كيف بده يكون اتجاهها؟ So B induced should be opposite to B. So here, this is B vector. So this will be B induced. Now, after I trace B induced, the last step is using right-hand rule. Then I will find the direction of I induced in the circuit. So using the right-hand rule, if I put my thumb on B induced, هيطلع معي إنه this will be like this, I induced. So هيك بكون حددت the direction of I induced, and here we have the answer. Another example, if the magnet now moves away from the coil, so what will happen? If it moves away, this means B is what? So this is B, so I have some horn. This means this is B, okay? So B, if I want to write it first, who's the variable? So B now is decreasing. Why it's decreasing? Since I'm moving away. So if B is decreasing, this means I will have creation of B induced. We'll try to what? To increase it. If it was, we will try to increase it, يعني لازم تكون معه with the same direction. So this means this will be B induced. So here, try to increase it implies B induced has same direction as B vector. This means what? So the last step, this means according to the right-hand rule, putting my thumb on B induced, I will get that the current I induced is in this direction. So this will be I induced. So I will find I induced. And here we have the solution.